Okay, here we go. Worksheet assignment, Unit 9, assignment 4A. Um, going uh, going to go over. I'm going to go over all of them. There's six questions. You guys all wanted to see them, and so I'm just going to go over all of them. If you don't need to see the one I'm going over, fast forward and take advantage of being able to be more efficient time wise instead of having to wait for me to get to your problem. Um, these are multiple choice. So first problem says let A sub n, B sub n, C sub n be sequences of positive integers. So they're saying they're all positive and they're sequences. So on their own, they're sequences, they're lists of terms. And all the A terms are less than the B terms are less than the C terms at whatever n value you're at. So then we're going to look at series, which adds all those terms up. And it says if the B sub n series converges, then which of the following statements must be true? Well, anything smaller than it will converge by comparison test. So here's an example of using a comparison test. And it wasn't very hard because they're just giving you certain information. Do we know that the C series converges? We don't know. We don't know if it diverges. It doesn't necessarily diverge. We just don't know what's happening with that bigger series. It could still converge. We just don't have enough information. Now, these right here, you might think, well, if we add A and B together, well, that's going to be bigger. We don't know if that's going to converge or not. But we can separate these series kind of like the way we separate derivatives and integrals, and we could treat each series as its own, find its sum, and then add the sums together. Well, if both of these converge, then they're going to add up to a number. It's not going to diverge. So this one is true. This one we don't know. It's not necessarily false. These ones are for sure true. So must be true is going to be 1 and 3. So that's number one. Number two, they tell you that the absolute value of a series of the individual terms of a series converges. Then which of the following is true? Has to be true. This is called absolute convergence. So this converges absolutely if you make all the positive and negative terms all positive and it doesn't diverge, then taking the absolute values away, it will for sure converge. It is absolutely convergent. That's just another term for that. If we put a negative in front, well, it's going to converge to the same the same thing that this converges to, but it's going to give you the opposite answer. In fact, we're able to do this. If that makes it better, this converges and it's just going to be negative. So they're all true. 1, 2, and 3. Number 5, what are the values of x for which the series converges? So this is the open form, and this is a power series, and we're trying to find the interval of convergence. I mean, I don't know. Is this a series that we know? Does it? That looks like e to the x or sine. No, e to the x doesn't alternate and actually has factorials on the bottom. It's not sine or cosine. So I think what I'm going to try and do is find the closed form, because that's what we usually work with when we do the ratio test to find the interval of convergence. So I'm just going to start n equals 1, n equals 2, n equals 3, n equals 4, and I'm going to try and find the pattern, and I think it's not too complicated. It's x to the n power over in, but there's also a -1 because it's alternating, right? So you can't lose that. -1 to the first term is positive, so it's going to be n -1 or n +1. So that is our general form, and that's what we usually use when we want to find interval of convergence. And this isn't a geometric series, so we can't talk about R value. We do the ratio test, and that involves taking the limit as n goes to infinity of the absolute values of the n plus 1 term divided by the nth term now. And then now we could simplify this. X to the n plus 1 is going to leave you x to the first power. We have x -1 to the n, -1 to the n. So that's going to leave you with -1 to the -1. That doesn't really matter because we're taking the absolute value. So that's going to go away. These don't simplify, but that's where you're getting n values left over. And it's going to be infinity over infinity, indeterminate form, but the largest terms are growing at the same rate. It's just going to be 1. So what we get is we get the absolute value of x. And we could get rid of the -1 because we're going to take absolute values. And it needs to be less than 1. So that means that x is between -1 and 1. Now, you might feel really good and go with answer D, but you would be wrong because you've neglected a very important thing that we're always supposed to do on intervals of convergence for power series is that we need to check the endpoints, and that's where there's a good amount of work. So let's maybe make some statement in our work about, hey, we're checking the endpoints, and this is the one I'm checking first, or the other one. Write down the value of x that you're going to check, and you plug that back in to the power series, and you get a number series out of it. So that means we're going to get n equals 1 to infinity. I'm going to put the -1 up front here, and we're going to plug -1 in. And then we could maybe try and simplify that. So rules of exponents, these are the same base. So it's going to be -1, and you would add these, and you would get a 2n 2n minus 1 over n. Now we could maybe just start writing the open form. If you're kind of like, well, what's that look like? We could try. We have all these different series tests to use. It looks like it's alternating, but what happens is when n equals 1, it's going to be 2 minus 1 is 1. It's going to be -1. It's going to be -1 over 1. And then when n equals 2, it's going to be 2 times 2 is 4 minus 1 is 3. So you're still going to get a -1. And when n equals 3, it's going to be 2 times 3 is 6 minus 1 is 5. So you're still going to get -1. So the that should be 2. The negative actually always ends up showing up. So it's not alternating. But you guys see this series? This is really the same thing as negative n equals 1 to infinity of 1 over n, which is the harmonic series, forced to be negative. It's harmonic. It diverges. And I'd be okay with that, saying that. Instead of stating some specific tests, you could do p-series tests on it. You could do integral tests, because that's where, harmonic series special case of. Let's try x equals +1, the other endpoint. So you got to test each one separately. So it's going to be -1 to the n minus 1, plug +1 in, and 1 to the n is just 1. And this one, when n equals 1, you get positive 1 over 1 minus the next term when n equals 2, the negative comes out. And the next term when n equals 3, it's positive, negative, positive. And so you should, I don't know, one way of figuring this out is to be, oh, that's the alternating harmonic series. And we know that the alternating harmonic series converges. You could use the alternating series test. You could use some other tests. You can't use the integral test unless you force them all to be positive. And then that'll tell you it diverges in its absolute form. So that's not going to help you. So we are going to keep x equals 1. So your final answer is -1 to 1 or equal to 1. -1 to 1 or equal to 1. This is the right answer. Answer C. So you have to check the endpoints. Now, most of the questions you guys had were on the back. So number 4. Okay. So what are the values of x for which series converges? So we're trying to find the interval of convergence, and here's a bunch of intervals. And so we're going to start with, for power series, we start with the ratio test limit as n goes to infinity of the absolute value of -1 to the n plus 1, x to the n plus 1 over natural log n plus 1. You should put parentheses. Divided by the nth term, multiplied by the reciprocal. So you set that up. You can try and simplify this. -1 to n, -1 to n. So you're going to have a -1 no matter what. X to the n, x to the n plus 1. You're going to have an x. You can't reduce those, but these are the terms that you kind of want to compare to each other. So as you go to infinity, it's infinity over infinity, indeterminate. You can do L'Hopital's, but really, natural log of 1,000,000 over natural log of 1,000,001, and really close. That's going to go to 1 as you go to infinity. So we get absolute value of -x, which is also the absolute value of x. Doesn't matter either way. And it has to be less than 1. So we're looking at x is between -1 and 1. But you have to check the endpoints. So some people would, well, I don't know. This answer isn't even on there. So hopefully it makes you worried that that's not the right answer, because it's not. So we have to check the endpoints. So even though it's multiple choice, this is work you should show, because this is how you're going to figure it out. And on free response or my test, you're going to have to show this work. So we could start at x equals -1. Plug it in to the power series. It gives you number series. The n values stay there. This is -1 to the n. So this is -1 to the 2n. And you could then do -1 squared to the n. So it's just going to be 1 over the natural log of n. Now, ratio test is me inconclusive. Nth term test tells you it goes to 0, which is good, but not good enough. It's not a geometric series, it's not an alternating series, it's not a power series. Integral test isn't going to work because you don't know how to integrate that. So I think the only thing left is comparison test. And that's always my last resort. Now, what you want to do is you want to figure out, okay, well, what's a series that we know is term for term smaller than or bigger than? And if we can get this one smaller than another series that converges, that's good. Then ours converges. If we can show this one's bigger than another series that diverges, then it diverges. This is what the graph of this looks like. So we're looking for, you can kind of think of it sort of graphically, another function that if you graph, this will always be smaller than. And one of these, this is a good simple one, is y equals x. And so this is y equals natural log of x. Now I'm really just focusing on the denominator. If I can show that this guy is smaller than these terms in the denominator, that makes these terms bigger than this one because we're dividing by a small number, which gives you a bigger result. And so, if you were to write this in open form, it'd be 1 over natural log of 2 plus 1 over natural log of 3 plus 1 over natural log of 4. And if you were to do this other one, starting at n equals 2, it'd be 1 over n, and that would be 1 over 2, 1 over 3, 1 over 4. And it's a harmonic series, right? It's harmonic, or p series with p value of 1. We do integral test, and this one diverges. And because natural log of 2 is smaller than 2, so just to kind of make it more obvious to you guys, natural log of 2 is smaller than 2. Natural log of 3 is smaller than 3. Natural log of 4 is smaller than 4. But that smaller denominator means this term is bigger than this term. This term is bigger than this term. This term is bigger than this term. So all our terms are bigger than these terms of a series that diverges. So ours diverges by the comparison test. So there's an example using comparison test. You're kind of looking for simple series that you can compare your series to, so that's a harmonic series. So that's where just being familiar with these. So that one diverges. We got to do the other one, x equals 1. So we plug x equals 1 in for the x value. And this one would be, when n equals 2, would be positive 1 over natural log of 2 minus 1 over natural log of 3 plus 1 over natural log of 4 minus 1 over natural log of 5. So this is an alternating series. I don't know. I think you could probably try a comparison test to it, but I think the easiest thing to do here is alternating series test. So name the test, limit as n goes to infinity of the nth term, and that's going to go to 0, which means it converges. Now, nth term test, that would be inconclusive, but this is the alternating series test. So if it's alternating series and terms go to 0, it converges for sure. So our final answer should not include 1, but it should include -1. So the correct answer would be B. Oh, shoot. Did I do that right? Oh, wait. -1 was the one that we decided didn't work. And this was +1. Gosh, I did all that work right. Very end. Almost lost it. So it's D. Most of the work on that problem, I mean, we got the first part done pretty quick. That was -1 to 1. It was those endpoints that took a lot of work. Okay. Which of the following series are convergent? Classic 3 questions in one. This one you might consider rewriting. Or I don't. It's up to you. I mean, it depends on how you want to deal with this. You could try nth term test, and it's always going to ±1. It doesn't go to 0, so it diverges by the nth term test. You could just say nth term test limit as n goes to infinity of -1 n plus 1, and it goes to ±1, which isn't 0, which means it diverges. I mean, you could. This also, if you write it out, if you start writing it out, when n equals 1, that's +1. When n equals 2, it's going to be -1, +1, -1. This is actually a geometric series. And the R value is -1 because it's times -1 times -1 times -1 times -1. So this is a geometric series, and the absolute value of R, which would be the absolute value -1, is 1 is not less than 1, and so it diverges. So you could use a geometric series test. I mean, I think nth term test was the easiest. Okay, so that one's out. So just by process of elimination, you could get rid of answers D and E if you really had to. If you weren't sure, you just made your chances better. This one, I mean, you could start writing the terms out. It's going to be +1 times 1, and then when n equals 2, that's going to be -2, and then when n equals 3, it's going to be +3, and when n equals 4, it's going to be -4. It's alternating, but the terms are getting bigger. So, I mean, you could just do nth term test limit as n goes to infinity of -1 n plus 1 n, and it's going to go to plus or minus infinity, which is not equal to 0, so it diverges. So that one's out. So anything with 2 in it is now out. So if you really had to guess, you could guess A or C, but let's see. This one, if you do nth term test, limit as n goes to infinity of 1 plus n over n. And what would happen is you would get infinity over infinity. So you do L'Hopital's rule, but the dominant terms, that is going to 1. And so it's like 1 to infinity, which is 1. So it's going to 1. The terms are going to 1, which does not equal 0, which means it diverges. So none of them work. And nth term test, I think, was the easiest way to show they all diverge. Okay, last problem. Which of the following series are convergent? So another 3 questions in one. What you might want to do, these are all in open form, and a lot of the tests that we do are for the general term. So you might, right here, this is the general term. So they're giving you the general term, the nth term. n equals 1 is the starting value there. So I'm just going to write these. Now, this is n to the 1 and n to the 1/2. So that's 1 over n to the 3/2. And it passes the nth term test, which doesn't tell you much. But this is a p-series. So the quickest way is to say, oh, this is a p-series. Let's use a p-series test. You would write down the name. You'd write the p-value. And then tell me that because it's greater than 1, it converges. If it's equal to or less than 1, it diverges. So that one converges. So anything that doesn't have 1 in it is for sure wrong. 1's got to work. P-series. This one, the terms, let's see. The terms do appear to be getting smaller. They're going to 0. And let's see. Let's see if we can. Yeah, I don't know. This is if you did a ratio test, if you did nth term test be inconclusive, ratio test be inconclusive. It's not an alternating series. It's not a geometric series. It's not a p-series. Now it is. I would say close to. So I mean, if you were to multiply this out, you get n squared plus n, and that means think about it. This series. That's a p-series with p equals 2, which converges. Ours has bigger denominators term for term, which means that they're smaller terms. So if you were to compare this to n equals 1, 1 over n squared, these terms would be 1 over 1 plus 1 over 4 plus 1 over 9. In our terms, 1/2, 1/6, 1/12. Ours, because our denominators have this little extra term to the n squared, they're always going to be bigger denominators than the one which is n squared, which means this is smaller than this. This is smaller than this. This is smaller than this. This whole series is smaller than this series. And since this series is a p-series, and the p-value equals 2, which is bigger than 1 and converges, since that one converges, then our series converges by the comparison test. So there's another kind of interesting use of the comparison test, and realizing that we're looking for really simple series that our series are kind of close to, that an easy series that we can prove converges or diverges and prove that ours are smaller or bigger than those terms. So anytime you have a series that has something that looks like another series that converges with a little extra in the denominator, well, then yours is going to be smaller than it. So that makes it. So I think 2 converges. So anything without 2 in it is out, but that needs 1 also. So it's either C or E. I guess that yeah, it's got to be C or E now, because there's only was a 1, 2. So 3. I think we just did this one. Didn't we just do this one up on number 4 for one of the endpoints? 1 over natural log 2, 1 over natural log 3, 1 over natural log of n. Sorry. See, we just did that. And what we did was we compared them to our harmonic series. So we said, okay, well, 1 over 2, 1 over 3, 1 over n. These terms are all bigger than these terms because natural log 2 is smaller than 2. And the way you can kind of confirm that, you can see this. There's 1. Natural log of 1 is 0. Now it's less than 1. natural log of 2 is less than 2. Natural log of 3 is less than 3. So because they have smaller denominators, they are bigger terms. And since this is the alternating, or this is the harmonic series, which we know converges, just because we remember it. Otherwise, you could prove it's P series, P equals 1, diverges. Sorry, diverges. Harmonic series always diverges. And since our terms are bigger than it, ours is going to diverge by the comparison test. So that one's out. So the answer has to be C. Okay, that's it. That's assignment 4A.